Hello everyone, welcome to today's webinar, CANSO Academy, How to Improve Aviation Efficiency Through Remote and Digital Towers, Part 2, Technology and Enhancements. Before we get started, I'd like to go over a few items so you know how to participate in today's event. You may have joined the presentation listening using your computer's speaker system by default. If you'd prefer to join over the telephone, just select phone call in the audio pane and the dial-in information will be displayed. You'll have the opportunity to submit text questions to today's presenters by typing your questions into the questions pane of the control panel. You may send in your questions at any time during the presentation. We will collect these and address them during the Q&A session at the end of today's presentation. It is my pleasure to introduce you to Conor Mullen, the Managing Director for Think Research and Associate Member Representative on the CANSO Executive Committee. Conor, I hand it over to you.
Thank you, Helen. Hello everyone, and a warm welcome to those of you joining us for this, the second in a series of 3 webinars based around the recently released CANSO guidance for smart and digital towers. I'm delighted to say that part 1 in this series was the most well-attended CANSO webinar ever, which shows that even though we've had almost a full year now of near constant webinars, and today is in fact Groundhog Day, the topic is still interesting and relevant. It also validates the work done by the CANSO Smart and Digital Tower Task Force, as they all made such great efforts last year in creating a valuable and importantly publicly available reference document for digital towers. Having given an overview of the guidance material in the last episode, today we're going to focus on the technologies behind the concept. So joining us today, we have 4 speakers representing the 4 main digital tower technology providers. We have representatives from Searidge, Frequentis, Saab and Kongsberg, and each will give us a short overview of their technology approach to remote and digital towers. Following that, we will have a Q&A, and please do submit your questions as we go along. Often when we're in the Q&A, we get a flurry of questions in the last 5 minutes, and it becomes quite hard to keep up. So as a tip, if you really want to get your question answered, I recommend asking it early. You'll have more chance, it'll be easier for us to spot. So since your ear might now be tuned into the sweet, gentle tones of Northern Irish accents, we're going to start with Neil Bowles, Executive Vice President, Business Development and Air Traffic for Searidge. With a 20-year career in air traffic and various operational roles developing technology strategies for ANSPs in both the UK and the Middle East, Neil is now responsible for business development and technology strategy at Searidge as they grow the business across ATM and airport markets. So Neil, as they would say back home, what's the crack?
Thanks very much, Conor. Becky, as we also say. It's my pleasure to join the panel today. Speak a little bit about the work that we did on, I was very pleased to be a member of the CANSO Smart and Digital Towers Task Force. And, a lot of work went into producing the guidance. It's been quite well received, what we can see so far. I'll just going to give you a little bit of an overview on what Searidge Technologies' approach to remote and digital tower is. And then I look forward to taking some questions and joining a hopefully interesting discussion. So next slide, please. So Searidge Technologies, we're based in Ottawa, Canada, and we have offices across key markets around the globe. We're owned by 2 ANSPs in NATS and NAV Canada. And we've been in business for over 15 years now, and have been providing systems firstly in Canada and then across Europe and the Middle East and the Far East as well. So I'm going to talk a little bit about our approach to technology and then focus on a couple of case studies. And hopefully this will be some interesting information that you maybe haven't heard before. Next slide, please. Okay, so So our approach to providing this technology is very much scalable. So remote tower, not every airport is the same, you know. So we prefer to bring an approach where we scale the needs, meet the actual visual and operational requirements of the system, and this means that an airport might have an HD camera or a 4K camera solution, depending on what those visual requirements are. You know, each airport always has some individual hotspots, some individual areas of additional surveillance, and that's our approach to remote tower. Digital tower is obviously, remote tower is of course a digital tower in itself, but the tower doesn't have to be remote from the operation. Digital tower can be on the airport site or somewhere close by. And a digital tower can build on the technology from remote tower, adding in additional views to augment the visual surveillance picture. Also, there's an opportunity to start integrating some data that might be available on a larger airport, such as ground surveillance data, and also some specific needs, such as you know, runway safety or other operational needs. Brings the opportunity to bring machine learning, actually AI enhanced detection and tracking to the system. Next slide, please. Okay, so the original remote tower case study is still very, very relevant, of course, but ANSPs and airports are actually looking at additional uses for digital tower technology. So it may be that an airport wishes to introduce an ATC service for the first time, or it may be that an NSP wants to replace a tower that's approaching end of life, and then is looking at a digital replacement rather than building a traditional bricks and mortar and steel construction. Or perhaps as airports expand and build additional runways, the need for building additional towers as part of that system, again, can be solved through a digital solution. And we're also seeing an emerging need for what are called hybrid digital ops. So augmenting the existing traditional tower with digital tower technology within that. And of course, another key one is contingency and indeed crisis resilience. That's a case study I'm going to focus on a little bit more, and we'll look at that in the next slide. Okay, so the past year with COVID has obviously changed a lot of ways that aviation operates. Pardon me. And one of those was with Hungaro Control's case study of their approach to the COVID-19 resilience response. So Hungaro Control have the R-Tower system in service, and it's been an operational certified service since 2017, mainly used for contingency and for maintaining competency of controllers. So 2020 saw a requirement for Hungaro Control to actually separate their airdrome control teams to reduce the opportunity for cross-infection with the COVID-19 virus. So what Hungaro Control did with the remote tower system, the digital tower system, was actually separate two teams, a day shift team and a night shift team. And the day shift operated from the digital tower, and the night shifts operated from the traditional tower. And they ran over 3,000 hours of safe operation during 2020 with this approach, and it's still in use for this situation. So the use here, this was never a use case considered, I guess, by most ANSPs. However, having that contingency facility has actually you know, enabled Hungaro Control to maintain a safe, efficient operation, and of course build up, you know, the operational experience and use of that system. Okay, next slide, please. So okay, so hopefully, you know, we're going to get some questions today, not just about current operations, but where we see the future that the technology is actually going to enable. At Sea Ridge, we see the digital tower advancing mainly through automation of some of the existing functions that may be either done by existing safety tools or some human decision making and suggestions. So there's the ability to enhance some existing safety tools with AI, so you get a more consistent and improved outcome from those tools. There's also an opportunity to look at some of the functions, such as route conflict detection, conflict resolution, turnaround events, and also runway safety tools, and enhance the safety and ability of those systems with machine learning capabilities. Also, other stakeholders at the airport will have access to much more shared ATM digital data. There's an opportunity as well to share that data in an ACDM environment to enhance, obviously, the overall decision-making capability among stakeholders, but also to join together ramp and ATC operations using shared data with separate systems, separate discrete systems, but the ability to have a greater view on what each part of the operation is doing. So digital tower is really not just everything we see at the moment, but over the next number of years, there will be an evolution of the existing technology just to enhance operations. So with that, I'm going to hand back to Conor, and thank you very much. Look forward to some of your questions very soon. Thank you.
That's great. Thank you very much, Neil. Our next speaker is Peter Gridling, the Vice President of Sales at DFS Aerosense, the joint venture between the German ANSP and Frequentis. Interestingly, in today's panel, Peter is a technologist with a particular expertise in camera and image recognition technology. He has a fascinating background in using automation and image recognition in the sports and television industries. And since 2016, Peter has been bringing that expertise to the Frequentis remote tower team. So Peter, we look forward to hearing what you have to say, and the floor is yours.
Thank you, Conor, for introduction. Yeah, my name is Peter Gridling. I'm in charge for remote tower technologies here at Frequentis. And next slide, please. I would like to introduce you in the German use case and in our German project, because the German project from the very beginning was intended to handle larger regional airports, not just small airfields, but really here regional airports in the size of 30,000 to 50,000 movements per year, and also with a mix of VFR and IFR traffic, because what we have seen in the past is that especially VFR traffic is much harder to handle than IFR traffic. And to give you a brief overview, so we have the remote tower center in Leipzig, and from Leipzig there should be controlled 3 airports in the first phase. The first airport, Saarbrücken, is about 450 kilometers away. The Saarbrücken airport is online now since more than 2 years, since December 2018. This year, the smaller airport Erfurt will follow, and we expect next year that Dresden, a larger regional airport, is following. And because of these larger airports, of these more complex airports, from the very beginning there was the demand to introduce additional safety features. It was not just about to see the traffic with cameras. So the idea of DFS was from the very beginning to introduce a system which basically supports the controller and increases safety in such an environment. Next slide, please. And basically, we have introduced 3 major features which are differentiating the German project from other projects. First of all, we have implemented a sophisticated box and follow system. So basically, that's an object detection system which detects and recognizes objects and brings situational awareness to the controller. This is done completely automated, and what we have learned in the past 5 years is that you have to provide a very reliable system here that the controller really trusts the system. And together with DFS, we have developed that system, which is now used by the controllers on a day-by-day basis. So it supports the controller in seeing birds, smaller objects, and even runway incursions, for example. And so far, Saarbrücken Airport is the only airport which has implemented these advanced features. Also, what we have implemented is that this box and follow function is not only fed by visual sensors, but also by infrared sensors. So in Germany, we have also infrared sensors in place, which enhances the view during night and bad weather conditions. And you can see a photograph on the right lower corner. So what the controller sees during night, where he normally doesn't see anything with the visual sensors. And in combination with this box and follow system, the safety level is increased compared to a traditional operation in a tower. Next slide, please. The second key element is a special pan-tilt zoom camera. So what we have seen in the past is that available COTS hardware, the performance of available COTS hardware was not good enough to perform really in an ATC environment. And therefore, Frequentis has developed a special pan-tilt zoom camera, a modular system, where in the basic version we have a high-performance visual sensor combined with an electronic light gun, and as an extension, you can also equip this pan-tilt zoom camera with an infrared sensor. And this camera system is really capable to perform in an ATC grade environment. And especially when we are not talking about civil use cases, but also military use cases, as we have in Brazil or also at the US Air Force, then this system now has proven that this system is able to perform the operations also in a high performance environment like a military airbase. You have to consider that fighter jets are much more faster than normal civil aircrafts and also behave completely different. So they maneuver completely different. And to follow such aircraft with an pan-tilt zoom camera, you have to provide a specific performance. And also this camera can be used with a sophisticated line of sight tracking. So basically you can lock targets and then the camera is automatically following that object, and that reduces the workload of the controller tremendously. So in our systems, the controller does not have the need to control the camera manually. So basically the typical use case is that he locks the target and then the system is automatically following this object. And again, here it's important that this tracking algorithms works as much as reliable as possible, so that you have that you really reduce the workload of the controller, and that not every time when the target lock is lost, that you then have to reinitiate the line of sight tracking mechanism. So you have to really rely on that. Next slide, please. So those have been the three core components of the advanced features Frequentis is providing, and that all three components have the target to adapt perfectly to the existing concept of operations. So DFS did not adapt any of the concept of operations, and since there are a lot of different customers and a lot of different concept of operations, it has been clear that our system must be capable to adapt perfectly to the specific concept of operations. And here on this slide, you see three totally different systems, including a multi-remote tower system where one controller is controlling 3 airports. And you see that the hardware setup and also the HMI can look like very different, and that's important that the software is capable to adapt that, and also that it's able to scale in the future. So thank you for your attention, and I'm happy to answer your questions in the later question and answer session. Back to Conor.
Excellent, thank you, Peter. We have a familiar face next as we welcome the co-chair of the CANSO Smart and Digital Tower Task Force and our third Vice President of Business Development and Governmental Affairs at ESTAS. That's Nicholas Gustafsson. And if you don't already know by now, ESTAS is a joint venture between Saab and LFE in Sweden. Nicholas has been working on remote and digital towers since the outset as one of the strongest advocates for what was then an emerging technology. And Nicholas's journey in digital tower has seen ESTAS open what was at the time the first fully operational digital tower in the world. And so Nicholas is an old hand, not just at digital tower webinars, but more importantly at integrating that system knowledge with operational and ANSP management know-how. So Nicholas, it's over to you.
Thank you. Excellent. Yeah, I'm gonna talk a little bit about, let's keep the history and look forward, I think, on this, where we're going, and there's so much that's happening with so much good input from many. Next, please. Next slide, please. Just a quick one. We tend to talk about technology, and all the time we have always been careful and making sure that we're not just replacing a system or an automation tool with another one. Moving to digital, even if it's on site, it tends to be all the other things as well. You're changing the infrastructure, and it has to be this operational certification and concepts and business cases. That sort of forms a part of that, and you know that, and we've been talking about it clearly in the material provided by CANSO. And now we're going to focus a little bit on the technical part here from Saab side. Next, please. First, just a use case. There's many of them, but I just picked this one, which was a new built airport, which didn't have a tower from the beginning. It was just cameras, and it got in operation, and the system was installed. I think it took us 12, 14 months to get in operation, and it just shows that sort of maybe this is, as someone pointed out, new airports may not be designed with the limitation of a physical tower somewhere in the middle. And this also got the CANSO Maverick Award for being agile and forward-looking, and it's sort of just interesting to see how this will impact the future of airport development and so on. Next, please. Just a thing now, for us, there's a new Skyline coming up, which may be cameras. This is the Saab variant, and the other ones equally good. I guess this is London City. This is up in some place in Sweden and in UK, and the other one is I don't remember. But this sort of thing is important, that this is smaller footprints. It's easy. It takes you maybe 2 weeks to install, and so it's sort of a new way of working. I agree it could do with some industrial design, that will probably happen. And here you see the traditional things with the PTZ and the infrared cameras and so on. And we try to, at Saab, be make it work. It's like a product thing. Yeah, every airport is unique, but we cannot go too many places. We have to find a streamlined product and so on. Next, please. Looking at that, one of our key things, maybe coming from the north, but also testing it in Australia and worldwide, it has to sustain. I mean, you don't want to have your eyes shut or anything like that. So we put a lot of effort in making sure that whatever these cameras do, day and night, they are protected and stay away from the weather, which is, as a Lufthansa pilot told me, it's also an airspace user. And that's we're taking as a very big important part. Make sure you see what you want to see and don't give the chance to have the opportunity to miss out the information. Next, please. I just picked a few slides here, and I asked Helen to pick. This is the first, was in operation in 2015. You see the screens, it's pretty much familiar. But as we moved along, next please, you can keep pushing here. There are new things, new generations coming. And they look the same, but we learn and you try to adopt the things, next please, in order to make sure you have the ability to both be flexible, but also trying to standardize things so that every customer doesn't need to sort of pay for a new upgrade or a specific adaptation every time. You can keep pushing. And there's a lot of installation, and we are in the second generation of these systems. And I keep saying second because the first one is pretty much about making sure that it works. The second generation about how it works better, how we learn to maintain, and the right hardware and software and so on, and the stability and the approval phase. This is the latest thing we work on, which is a smaller module, which has the capabilities of having less footprint and for specific adaptations and so on. Here you see a lot of things working on screen rather than looking down and so on. That's an important part, I think. They're fed by the controllers. They want to look ahead and look at the airport. Next, please. Yeah, the same thing here, flexibility. Saab has, our core is the sort of regional airport, which is certified and so on. Right now we see that these things go in different directions. There are the RAM tower areas where larger complex airport, there are other large ATC airport which needs more features, as someone said, with IRs and the flexibility and adopt that. There are military things that is coming. Just going to go live with the German airport in Gridling with the first sort of military airport and other places. And then there are the sort of the more lighter versions of that adopted to these specific scenarios. So that's our product roadmap idea, that trying to keep it consolidated while expanding in this certain direction in order to keep a family of remote tower products. Next, please. Yeah, it's mentioned before, digital possibilities, and these are fed into or included in the product as we move along. Everything from the infrareds, PTZs, the way we use online things, box and follow, also used here in Saab, and then of course the things that is down the road here with the AI enhancements will eventually be there, and the way we introduce UTM and so on in the center and so on. So these are the things, the toolbox that needs to be adopted or can be adopted using our tower to make sure that it's sustainable not only for today but also in the 2030 plus time frame. Okay, next please. And I think I just wanted to share this. Where are this going? And the way we work in our design work and our mental thinking with the operational cases and our customers, not to say the least. We have a user group in Saab that is involving all our current customers and working with them to try to find what will be the requirements for the future. And then I strongly believe that there will be a center of towers where you can have regional airports or larger airports or contingency blended in a way that fits for that country or that region or that company. We mentioned integrated training, joint supervision. We see this rostering staff in the planning, how you mechanize, not only make it work, but how can you use your staff and equipment in the best way. And of course, the military things. So thank you very much. I think that was the last one. And I want to sort of really thank you for the good work done by everybody.
Thank you, Nicholas. Our final speaker is Stig Jensen, Director of Business Development, Aviation and Security, Integrated Defence Systems with Kongsberg, the defence and aerospace company in Norway. With 16 years in the Royal Norwegian Air Force and several years in management consulting, Stig has been with Kongsberg since 2008 and since 2015 has been leading the business development campaign for the Kongsberg Remote Tower solution. Many of you towards the end of last year will have seen the quite beautiful pictures of the Bodø RTC, where Kongsberg, Avinor and Indra are rolling out digital towers to 15 airports across Norway, and I believe are already 4/15 of the way in. So Stig, it's over to you.
Thank you so much. The Kongsberg Remote Towers brand is based on the system that we are implementing and delivering to Avinor in Norway. And our approach to this has been kind of using technology that we already have available from the military sector, since we are a defense contractor company. That's where we come from, and using this for different purposes. And when somebody's looking into remote towers or digital towers, it's different strategic approaches that can be chosen. For instance, having a strategic top-down approach, as we see some of the customers, for instance, Avinor, and we see some other European customers, wants to have a strategic top-down approach and actually installing a full system that will replace the already available system that they have, the traditional remote towers or the traditional brick-and-mortar towers, or actually starting with in a smaller scale, going in there and actually gaining some experience, gaining knowledge, and starting with one airport with a simple operation. Different approaches, and it's important actually, I think, is to think through this before you actually start your programs. Next slide, please. So that's why we can say the ecosystem for the integrated system for remote and digital towers consists of many different elements. And this is just one perspective, one aspect to this, where the remote tower module will be the center, actually, where you have the control of work positions. It could be 1, it could be 2, it could be 3. It's different from the size of the airport and the operation, of course. Integrating the different elements of an ATM system into an air traffic service is something that is needed, and you will of course need communications. We know that. It could be an advanced VCS system, or it can be a local system, which is simpler. The surveillance, or what you actually can see, because when you are in the cabin, you can look out through the window and you can see what's going on at the airfield and around the airport as well. And you can also have a radar screen and having surveillance information available. For a remote or a digital tower, you need, of course, to replace your own out-the-window view with cameras, sensors, and make them available to you. And then you can add in other surveillance information as well. The airport ground equipment like runway lighting, MET systems, crash alarms, ILS systems, and so on, or the CNS systems. Implementing them is something which you have to do locally, or if you're operating remotely. And of course, also the level of tower automation systems. Could be surveillance displays, electronic flight strips, and so on. You don't have to replace everything. You can use your legacy systems. You can basically, a good solid architecture, a sound architecture will enable you to implement your legacy systems and use them as is. So that's a kind of the judgment or an assessment that you need to make before you start a program. And the more you implement, the more you buy new, the more you want to digitalize, the more complex the program, the implementation case, this verification, the validation, the safety case becomes. I think this is, we as technology providers and also ANSPs who are getting more and more knowledge in the subject area will be able to together make a viable path that can be used for implementing the capability. Important is that this is modular, it's scalable. You can use it for a small operation, a smaller airport. You can implement it for a larger airport with many movements, maybe 2 runways, then you will duplicate. It's a business decision on how you actually want to set up the redundancy and all those different kind of capabilities. But as we all know, safety comes first, and all the systems available in the market now is designed to be approved by EASA and international regulations as well. So the modularity and integration of systems and information is a key aspect to this. And I think we all want to say that this is something we can support. And growth, UTM has been mentioned, all the different capabilities. We will see more autonomous operation. Integrating that into a remote tower architecture is very important. Next, please. However, we should not forget that we are replacing the cabin. The air traffic controllers still need an out-the-window view, needs to be able to maintain a continuous watch on all flight operations. For us, it's been important to install camera systems that can actually give you that overview. So a terminology is being used a lot now is a DRRP, detection and recognition range performance, defined by EUROCA in the working group 100 work ED240. And so having systems which is able to detect having the same capability as the human eye is important. It's a panoramic image. And new with the technology is, of course, coming in with IR Specter sensors in addition to the visual Specter sensors, and the ability to fuse IR with the visual Specter. It's a huge help for operators during lower visibility conditions and, of course, darkness. And in addition to having a better image and to be able to detect and see what's going on in your area of responsibility, we can also augment information like surveillance data, meteorological data, and also add kind of artificial intelligence features like detecting moving targets and recognize objects out there. So in total, you will actually be able to see more, getting more help actually for getting a better situational overview for the situation from a traditional operation. Next, please. So I would just like to highlight the case we have with Avinor with the remote tower center operations. Of course, implementing this technology, making it safe, getting it approved by the authorities so you can go live and commission and move the operation, transfer the operation from a local operation to a remote tower center is very, very important for the business case. And there are several advantages operating for a remote tower center. On this picture, you can see the upper picture there. You can see the brand new building built by Avinor in Bodø in Norway, which is just above the Arctic Circle. And the pictures you can see there is from the grand opening of the remote tower center last fall. The bottom two pictures you can see there is from the contingency center that is now being operated with 4 airports being remotely controlled from the contingency center. And the first flight was operational in October 2019. And the transfer to the larger main remote tower center is planned for May in 2021. 15 airports will be operated by the end of 2022 from that center. And I'm happy to take questions that you may have. Thank you.
Excellent. Thank you, Stig, and thank you indeed to all the speakers. A reminder that if you haven't already done so, please feel free to register for the final webinar in this series, and where today we're looking at technology. In the 3rd episode, we'll hear from the ANSPs who will give their experiences about their implementations and the case studies. And interestingly, we currently have 7 ANSPs all lined up to speak in 2 weeks from today, and that will include some who you might not have heard too much from in the past, so should be worth tuning in for. Okay, so for the remaining 23 minutes or so, we're going to take some Q&A. We've had quite a few already. We're even going to bring forward some Q&A that we didn't answer in the last session. So speakers, if you're all ready, I'm going to, whilst we wait for the absolute rush of questions, I am going to start with a high level. So being that today we're focused on technology, and all 4 of you, in fact, can call yourselves pioneers in the technology of digital tower. What do you think is the biggest lesson that you've learned about the technology in the last 5 or 10 years? I'll ask Niklas first, just as his position of power as co-chair.
Okay. Yeah, thank you for the question. Well, I don't know where to start, to be honest. I think the lessons is it's moving from the fact that initially it's all about a lot of thinking about cameras and what you can see and so on, and that I think has come to a level where it works, and now it's sort of, I think, is moving more into the direction of how can you operate efficiently, and so that controllers and the management and so on can, as you saw, 15 or 20 or how many airports you have. I think that shift of focus is something I've learned a little bit, and it's not always the initial thing that you believe is going to be the crux that is there. I also see there's always a lot of need to work closely with the users, so that all this sort of, it's more than just the camera, it's infrastructure, it's regulation, and all these kind of things that needs to be in place before you can hand over it fully. That is sort of my at least one of the experiences.
Okay. Neil?
Yeah, absolutely. To be honest, you ask about the technology, but the technology is really only a part of it. The human change management process is at least as important. Obviously at Searidge Technologies, we have a background in bringing this technology forward, but with our shareholders in NATS and NAV Canada have a huge experience in bringing operational systems into operation, and we've been able to learn quite a bit, from them as we've brought systems into operation as well. So really the journey starts with, yes, you have some technical requirements, but to be honest, it's getting your stakeholders involved early, and building that change management process up from the start, engaging the right stakeholders. Very, very important.
There's a message, in fact, we touched upon that message in webinar 1, where we talked about the validation and the life cycles that come after FAT and SAT. Peter, as a technologist yourself, what do you think you've learned about the technology and the 5 or so years since you've been with Frequentis?
Yeah, I think the major learning was that the technology is there basically, but the application is important. So sometimes not only some technologies sometimes make no sense to be applied if the user doesn't accept it, and therefore an early involvement, what we have already heard from Neil, is important to early involve the air traffic controllers, that technology is really used on a day-by-day basis, and therefore the technology has to be also reliable, so that it's not just a fancy feature, it must work in a day-by-day business, and then finally also that it's accepted by the regulator, and finally it should support the controller in their daily work. It should not overwhelm them. So, and therefore, and that's I think one of the major learnings of all of us, I think.
Okay. And then finally, Stig, because yourselves in partnership with Avinor have been looking at this for a long time, and in the last, I suppose, 6 months, the implementation acceleration has really kicked in. If you had a technological time machine, what do you wish somebody had told you 5 years ago?
Lots of things, actually, because I think it's important to look at this as a life cycle of, and it's a complex implementation process. I think what we have seen, I think what we see in the market, it's maturing right now and moving from very detailed technical specifications into more performance-based requirements, which I think is important for everyone, because it's all about thinking holistic on the operation, the whole concept of operation, how the actor will actually have a system available to do his mission. And there are different technical solutions, yes it is, but we see kind of the elements. There is a visual component, there is some remote control component in this, and so on, etc. But I think we're moving over to performance-based, and a more holistic approach is very, very important for all of us.
Okay. And you mentioned the word life cycle, Stig, and interestingly, one of the questions that was asked during webinar 1, which we promised we'd take forward to webinar 2, was about the life cycle. And the question was, whenever we have enough experience with a lot of the more traditional ATC systems to know what their lifespan is, what their life cycle is. We're maybe not quite there with remote and digital tower yet, but Nicholas, you talked about second generation. What do you think? Well, have you any ideas at the minute about what a lifespan or a life cycle will be for this technology?
I think it's just more about taking a little top-down approach to architecture. You really need to accept that. We know, for instance, that electro-optical sensors, what we saw 5 years ago and what we saw 10 years ago, is very different from what we see today. How we see data being processed, what kind of software components, safety nets is available, it's moving forward. And having an architecture which is open, component-based, meaning that in a life cycle, you will swap components, you will swap sensors, you will swap different means that you use for decision making, and you will move in new capabilities like UTM has been mentioned. We all understand that UTM into an airport is something we need to take into consideration. Autonomous, we have in Norway snow plowing, autonomous grass cutting, and etc. etc. So having you need to understand that you govern for a lifetime experience with your architecture, but you have to be able to change your components and new capabilities with new technology.
Okay, Nicholas?
Yeah, just a thought. And the first system we got approved was sort of it's getting close to 10 years. And just one of the things I noted, it just keeps on going. You could expect maybe there were significant hiccups and so on, or the cameras didn't deliver and so on. But that seems to be working. And I think that's good from a perspective that you don't need to update that sort of the cycle doesn't need to be 5 years and so on, at least for the things that is out on the airports, and that's one learning. When I talk about second generation, is that okay, that with that, how do you keep the cost for or the power and the electricity and the data sets and so on down to and the maintenance and so on, because that's part of this life cycle process and learning and so on. And I think that's one key. And then of course we are, as you say, growing up now. One of the things on top of the head is, okay, how is the technical refresh look like? How do you exchange the first generation to the second and so on? And I think that we're getting fast into that discussion, but it keeps on going, and I think that's important. Otherwise, sort of we're in a tricky to motivate replacing the current with a lot of technology. That's a key thing.
Okay. Neil or Peter, anything to add?
Yeah, just building on what Nicholas is saying a little bit. We're starting to see requirements for extended maintenance and support life cycles with systems now. 18, 20 years in some places, and that raises a really interesting question about, yeah, what is the sort of the equipment refresh cycle? Like Stig and Nicholas have said, we've got sensors in the field that are still working absolutely fine in excess of 10 years, and really. I think the platform is kind of key. If you have an open architecture platform, you can swap components out as and when required. And it may well be that it's just technology becomes obsolete in terms of the optical sensors before they actually stop working. So it's really a question of each NSP can address this. But yeah, you're looking at an 8 to 10 year life cycle, no problem.
Okay. I want to move on then to the next topic, and Peter, I'll give you the first chance to answer the next question, don't worry. We've done as a team, we've done quite a few of these webinars over the years, and it's interesting that in this series, one topic keeps coming up more than most, and I don't know if it's because of where we are in the world. We're all working from home, and in 2020, the most valuable commodity on earth was network bandwidth, good internet. We're getting a lot of questions actually on the bandwidth requirements and the network infrastructure requirements on digital tower. We've talked a lot in the past about cameras, and I appreciate the two go hand in hand, and all of you will have a lot of experience from the Eurocry working group where this topic was discussed in detail. So what can you tell us about the bandwidth requirements, the network infrastructure requirements? And then as a follow-on question, we've had an interesting question. Is there currently any remote or digital towers using satellite connections? Obviously, we have in en route, we have space-based ADSB and so on. So what can you tell us about where we are with network requirements and bandwidth requirements, and where we're going to get to? And I say, Peter, I'll let you have the first go at that question.
Yeah, thank you very much. Well, it's important to know that dependent on the use case and dependent of the system, the network requirements are changing. So they can start with very small systems with a bandwidth of 20 megabits, but also for large systems, you maybe would like to have 80, 100, or even more bandwidth to send in a proper image quality. But the bandwidth is not the only performance indicator. It's also the quality of the network, and therefore, and that's often underestimated by the customers. And therefore, a special quality of service tool is needed, because what we have seen in the past is that commercially available networks are not really ATC grade. Of course, there are some technologies to make a hot switch over or something like that. But when we are talking about the brownout detection, so basically the network quality is still alive or is still good for the telco, but it's not good enough anymore for remote tower applications, then it's important to know that and to react on that. And I think that's also one of the major learnings in the past years, and in the future it will be even more important, because we see that low orbit satellite connections are coming, so they would be able to connect in the future remote towers for remote islands or all places where the connectivity is not available at the moment. And especially when we are talking about this connectivity, then you have to take care on the quality of service via this network connection.
Okay. And Stig, I know this was something that you guys considered quite a lot because of, I guess, the sheer distance involved in the cluster of airports that you're looking at in Norway.
Yes, absolutely. And there's a firm requirement that we need to be able to present anything that happens on an airport within a second on the screen in the remote tower center. And that requirement is still very firm, and it's a hard requirement. And as long as that requirement is there, everything will be built for that, having that professional network capability, to put it that way. Yes, bandwidth is one issue, but as you said, quality of service and latency performance is just as important. And we, like we did in Norway, working with a national provider of network services, Telenor. Everything in Norway ends with Nor, by the way. But so getting there is like Avinor, of course, did that contract with them and putting in those professional requirements, and they responded also with redundancy capability for this purpose. If we want to do satellite services, well, the challenge is, of course, that we have some latency challenges with using satellites, and we know that for sure that cybersecurity will put more stress on the data exchange, not less. There will be harder requirements for cybersecurity, and I'm not sure that there is not a simple fix to this. The network requirements will be there and will be challenging for all of us. It will cost money.
Okay, you mentioned cyber, and again we're getting a couple of questions on cybersecurity, and I'll move across now to Neil or Niklas, whoever wishes to go first. Obviously, when we think about removing something from a local direct vision and then putting that same sense over a network and digitizing it, instinctively we think there must be a greater risk for cybersecurity here. So is that the case? And if so, what can we do about it? Or is it in fact a problem that we see? Is it no different perhaps to the problem we have in other ATC networks?
Okay, yeah, I can start. And I think cybersecurity it's of course an issue, and it's not only network issues. I think everything from the fact that there might be intrusions at site or off site and all this kind of things. So it is something that we see, and I think we all do, an increased request for making sure that we are as resilient and so on cybersecurity as possible, which is always a trade-off. The safety, you can be very secure, but then you have maybe issues with the flight safety because you have to operate it in a flexible way, and so that I think that's where we are on this one. It's one of our top priorities in Saab is to how to evolve this protection or cybersecurity on-site network and at the airport in a good manner, and it is a challenge, and I think we need to live with that and increase that over the coming years in order to make sure we find a level where you have a flexible operations and a secure operations in the center.
Okay, Neil?
Yes, the air traffic control tower has always been the most visible part of the ATC network, to passengers, to anybody really. But the requirements, for safe, secure communications apply across the whole ATM system, en route, approach control, as well as aerodrome. It being a more visual aspect, people, maybe have a concern, especially as it's video technology. Could that be interrupted in some way? The requirement for a safe, secure network and resilience is very, very key. It's also key that when you're implementing the technology, you're building in resilient procedures, fallback procedures as well, to be able to adapt to any interruptions should they occur.
Okay, thank you. Now, just as an interlude, thank you very much for all your questions that you've been submitting. We won't get through all of them, I'm afraid, but what we have committed to do is taking all the questions from all the webinars, and after this we will send out, CANSO will send out a written response to each and every single question that we get. So even if we don't cover yours in the remaining 5 minutes, you can trust us that we will answer it in one way or another. So Neil, just to stick with you then, I think it might have been you that mentioned at the start about blending the digital tower technologies into a what do you want to call it, a local tower or a traditional tower. And we've had a question on that topic. What do you think the potential for that is?
I think that's, and we call that kind of operation a hybrid operation. I think it's got a huge potential. So, so not every airport in the world will convert to a digital tower. Some will have reasons for maintaining a traditional tower and even building new traditional towers in the future. But what there is there's an opportunity to harness the capability that comes with digital tower and augment an existing tower operation. So we've been through that process. We supported DSNA during the refit of the Paris Orly tower. We supported them for a period of 6 months while that refurbishment took place, operating from a room within the VCR with a more limited view. And we were able to provide ATC grade digital tower technology into that temporary operating room, so that they could see, the blind spots that resulted from moving that out of that optimal viewing space, was able to be augmented by our system, and they were able to to harness all of the capabilities like Stig mentioned, the 1 second latency requirement. So they were using the digital tower technology alongside looking out the window in a traditional visual concept of operation. It was very successful, and after the new tower had been outfitted, the controller still wanted to maintain these camera views. So it's an ongoing process to integrate those into the new VCR because they saw the use of them. And I think this is an area we'll see a lot more growth in. There's some very, very large airports around the world, looking into this concept right now. Okay, thanks, Neil. We have a little bit over 3 minutes left, so I want to ask you some kind of quick fire. I'll ramble on with the question if you give me quick fire answers. So we're getting a lot of questions about the ability of digital tower to support safety or improve safety. So very quickly, what do we think we can do with technology to help improve safety? Bearing in mind we originally came from a cost-driven background. I'll go to Stig first.
So I think it's about integrating information which is already available from different sources into one pane. I think the head-up display is the key here. Adding more information there and also build logics into it, like logic for safety into the decision. Okay, cool. Peter?
Yeah, from my point of view, additional support features will increase the situational awareness of air traffic controllers and therefore also will increase safety if it's done in a proper way. So if it's not overwhelming the ATCO and really is a support tool, then it definitively will increase safety in the future.
Niklas?
Yeah, I think the awareness, the fact that you will have in front of you the information you need for the task you like to do at that time, not overloading with things, but as depending on the airport and site, you can add tools to that, as Stig and Peter is saying. So I think this awareness is something which give the main safety for the future.
And Neil?
Augment the digital tower out the window view with additional views distributed around the airfield, bringing blind spots and distance thresholds closer to the controller so they can see what they need to see when they need to see it.
Okay, thank you. And then I'll stay with you, Neil, for the next quick answer question. We've had a few questions from the audience about multiple remote tower. Now, we know it's not quite as mature as what we have at the minute today, but if we think about what technology might expedite its implementation or enable it, what do you think about what technology do we need to get to a multiple operating mode? I'll start with you, Neil.
I think very good demand and capacity balancing tools, so that supervisors and controllers would have a very clear indication about what the traffic levels are going to be in the short tactical term to enable switching between those airports.
Okay, Niklas?
Yeah, that's true. I would like to add also, I think it will be automation and voice comm needs to be a little bit more integrated, so you don't have to fiddle around too much. That's the support you need. And from our side, we're good to go on this. We're sort of just waiting for the COVID to pass here so we can start the finalization of it, because it adds value to some parts of the type of airports.
Peter?
Yes, I also think that the specific support tools like the automated object detection, like the integration of voice communication system, which all should support the controller and reduce his workload, that will lead to the multi-remote tower successfully.
And then Stig.
Yes, of course, I agree with what's been said. It's all about keeping the operation safe. If you have a number of airports and the activity goes up and down, you need to understand the activity level for each airport and being able to actually, it's all about delivering the service for the users at that specific airport. If it's through multi or it's actually being able to scale up and in and out for supporting that specific airports. That's part of the concept of operations that has to be go through, and training of operators more than anything else, I think.
Okay. Thank you. So I'm going to finish then with a final question to you all. And I suppose we started by saying, what technology lesson do you wish you'd learned 5 years ago? If we look forward now to the next 5 years, so it's 2026, the world is hopefully a much more better and well-traveled place. What technologies are we using then that you're most excited about developing now? And I'll start with the technologist himself, Peter.
I think from my point of view, it will definitely be the use of artificial intelligence in a safe way. I think that's the major challenge with artificial intelligence. So currently it's a research topic, and the challenge is how to convince regulators to allow that artificial intelligence is implemented in a daily use for the air traffic controller.
Okay, Neil?
Yeah, I would agree with that. I think the introduction of AI, very much keeping the human, at the center of the decision-making process, but supporting them, with suggestions for operational decisions, and basically proving to regulators that this technology is safe.
Cool. Stig?
Yeah, I think it's well, we can go blind in all kinds of different technologies, but keeping it simple, keeping it safe, and using this for a better situation awareness, which is more efficient actually for the operation.
Yeah. And then we'll give the last word to the chair of the group, Mr. Gustafsson.
Yeah, thank you. Yeah, I think, of course, that I also think as I told you, that I think this integration of centralization of things, we will see many airports working together. We'll see people change between airports and multiple users and so on. I think that still is an exploited area which we need to exploit more, the benefits of working in a center. I think that's something I would like to add to that. And that, of course, includes tools that you need in order to make that happen.
Okay, brilliant. Well, gentlemen, thank you very much for your time today. And thank you to the several hundred of you again who were watching. Don't forget, we have the third and final part of this series on Tuesday, the 16th of February, 2 weeks from today. And as we say in that one, we're going to be talking to the NSPs about their case studies and about the lessons they've learned through trying to implement or procure or develop their own specific digital tower programs. And as I mentioned earlier, of the 7 speakers we currently have lined up, 3 of them currently you might not have heard too much from before. So it'll be very interesting to hear what these next generation of implementers are planning. So thank you again. As I say, we will get around to answering all your questions once the webinar series is over. We will send those out with all the various information. We're going to hand back now to Helen, and I look forward to speaking with you all in 2 weeks' time. Thank you very much. Helen.
Thank you, Conor, and thank you to all our speakers today. And thank you everyone for attending. Once you leave today's webinar, you will receive a survey, and we would appreciate if you would complete that, provide your feedback for us. So on behalf of CANSO, thank you for joining us and enjoy the rest of your day.